All right, so today we're going to finish section 2.3, and I want to remind you where we left off last time. We were in the middle of working on Venn diagrams, and we had just done our last problem where it had three sets, so three overlapping circles. We put numbers in all the locations. We worked inside out and the parentheses out, and all that good stuff. You guys remember where we were? Okay. We have one more example of this variety where we're going to be shading, and this one is going to actually have sort of some pieces of the last two things. So on part A here we had some complements going on, and on part B we had the three sets going on, so we're going to do both now. We're going to do A intersect, whoops, sorry, right one in there, B complement, intersect C complement. So for starters, how many circles do I need? Three. Alright, so we're going to draw a rectangle, and we're going to draw our three circles. What's our next step? Label them and number them, both of them. We'll do both at the same time. So here's U, A, B, and C. And I'm going to put my numbers across the top. 1, 2, 3, the middle, 4, 5, 6, 7 on the bottom, and 8 outside in the rectangle that's not in the circles. Okay, now I've got my diagram, so we're starting. What do we do next? Yeah, and actually I'm only going to do the parts in the parentheses first. So I'm not even going to do the whole piece, all the pieces. I'm just going to do A first. So I'd like to know, and why am I doing A and not A complement, for example?
Because A complement is
right. This piece right here in the parentheses doesn't have A complement, it has just A in it. So I don't need extra things that are not in my problem. A, however, is in my problem. So what numbers are inside of circle A? 1, 2, 4, 5. And then the next one that's inside of my parentheses is actually B complement, not B. So I don't need to write down B, I need B complement. What does B complement mean? Everything outside of B, or not inside of circle B. So what numbers are outside or not inside of circle B?
1, 4, 7, 8.
1, 4, 7, and 8. Don't forget the 8, because it's part of it too. Now what? Yeah, now I can do everything that's in the parenthesis, and this particular parenthesis has an intersection of these two sets. So what does it mean if it asks me to find intersection? What's in both of them? That is what's in common to both, correct? So what is in common to both of these? 1 and 4. So I've got 1 and 4. That's the pieces that I'm going to be working with now. Then what? Now I need to do C complement. I'm done with everything inside the parentheses, so I'm moving outside the parentheses. What numbers are in C complement?
1, 2, 3,
8. Good. 1, 2, 3, and 8. Now what? Okay, so now I'm supposed to do the whole expression together. And this expression has A intersect B complement, so this set that has 1 and 4 in it. And I'm supposed to find out where it intersects set C complement, which means what am I looking for? Okay, so the question is, do I include everything, or am I only looking for what they have in common? This one's in common, and why? Because it's intersection. All right, so I am looking for another intersection on this one, so I still look again for what they have in common. They only have the number 1 in common. And so that's my answer to my numbers, but the answer to the problem is actually to shade. So I need to come back over here and shade number 1. Is that good? Okay. There are other things that we can use Venn diagrams for. So we're going to do an example of a Venn diagram with some information. So this one says, draw an appropriate Venn diagram using the given information to fill in the number of elements in each region. Now, there's no given information right now. I'm about to give it to you. Your book will give it to you from the get-go. The reason it's not in there now is because the programs that I used to create these don't always cooperate with all my symbols, and they don't like the intersection union symbols all that much. So that's why it's not in there. So let me show you what our pieces of information that we are given are. I've got n of A is 24, n of B is 24, and n of C is 26. N of A intersect B is 10. N of B intersect C is 8. And N of A intersect C is 15. Here's two more. N of A intersect B intersect C is 6. N of U is 15. All right, so taking a look at this, hold on just a second. Okay, so taking a look at this, the first thing we have to figure out is when I draw my Venn diagram, how many circles am I going to have? 3. Do you see all 3 of them? A, B, and C? Okay, so I'm going to draw a Venn diagram, the outer rectangle, and I'm going to have 3 circles. And I'm going to label them, right? U, A, B, and C. Okay, so what we're looking to do is we're looking to put the values inside of each of these places. I'm not shading any regions anymore, like I did before. When I was shading the regions, I put the little numbers in all of the different regions. Here, the numbers mean something different. Here, what they mean is they mean how many items are in that particular set. Right? So here's the problem. If you start with the information at the beginning, you've got an issue. Here's the issue. This says N of A is 24. Take a look at circle A. Circle A has 4 different regions. Do you guys see that? And all 4 of those regions combined have to equal 24. So that piece of information is not entirely helpful because I don't want to guess and check with 24 and try and figure out what different options I have for putting these numbers in. Does that make sense? So all 3 of the first pieces of information, highly unhelpful. The second 3 pieces of information in the middle here, they talk about values where they intersect. Now take a look where circle A and circle B intersect. They're intersecting in these 2 regions. Because that's better than 4. But still not so helpful, because if I want to deal with the number 10, I have to do all the combinations of things that could be 10. So I can do 10 and 0, I can do 5 and 5, I can do 6 and 4, or 4 and 6. I don't want to guess that checking that either, okay? However, when we get to the next piece of information, this is very useful. What is this one describing? Yeah, that's the very center. It's the point where all 3 of the circles intersect. That's only one location. That's a good piece of information to start with. So I'm going to start with this number 6 in the very center. So you're looking for whichever piece of information gives you the one location that you can fill in. It's almost like when you do a puzzle, like a Sudoku puzzle, right? You don't just randomly decide where to start. Not exactly anyway, because you don't have that much freedom. You don't want to do that much guessing. You look for what you don't have to guess about, and that's what you're doing here too. Now that we've got this piece of information taken care of, I'll underline them as I go. That middle line is actually very helpful because it's telling you where 2 different pieces overlap. Let me just start with the first one, A intersect B. Well, before we had the A intersect B, and I talked about the fact that there's 2 different regions of it, right? And we didn't know what either one of them were. Well, we do know what one of them is now. One of them is 6. So what's the other one going to have to be? 4. And it's going to have to be 4. How come, Becca?
Because both of those parts are 10.
Both of those parts added up have to be 10, exactly. So I actually have to have those 2 regions adding up to this value here. We're going to do the same thing for the next one. This one is B intersects C. Well, here's circle B and here's circle C. They intersect where the 6 is and where this blank space is. So what does it have to be? 2. Right. The last one where they double over is A and C, and A and C intersect at 15 in this region right here. So what goes on the outside here? 9. Is everybody making sense with this? Okay. All right, so you're going to go across the top the same way we did before. This is N of A is 24. Well, circle A has 4 pieces. Thankfully, we know 3 of them now, don't we? We know 9, 6, and 4, which add up to what? 19. So how many more do I need in the outer part of A? 5, because they're supposed to add up to 24. Circle B, also going to add up to 24, but circle B over here currently has how many in it? 4, 6, 2, which is 12, which leaves me with needing 12 more. Very good. So we're done there. Circle C down here at the bottom is supposed to add up to 26. How many are in there right now? 17. So how many am I missing? 9? It's 9, right? Okay, just checking. Yeah, 9. Going to give me that 26 that I need. What have I not filled in? The outer part of U, right? The part that doesn't have any of the circles currently in it, so to speak. But I have one more piece of information I can use to do that. What is not true is that 50 goes on the outside. What does N of U being 50 actually mean? What has to equal? Right. So everything inside of the rectangle, including all the pieces that I've already filled in inside of my circles, have to be 50. So I need to add up everything inside of my circles to figure out how many I'm missing. So I have 5, 4, 12, 9, 6, 2, and another 9. What's that add up to right now? 47? So how many are missing from out here? 3, because it's supposed to add up to 50. Okay, does that make sense? Okay, I want to explain how to do that first, because now we're going to actually use some context of why in the world we would want to do that. Because to me, this just looks like a puzzle, like Sudoku, right? You could give me one of these and we can pretend like it's a puzzle, and that's fine. But that's sort of just like the thing I do in the car while we're waiting to get somewhere. It's just a time filler. But let's actually see how it can be used. We're going to do 2 examples. Joe Long works on albums for musicians. Last year, he worked on 12 projects. He wrote and produced 2. He wrote 5, and he produced 7. And then we have some questions that we're going to be asked about how many he wrote, how many he produced, and so forth. Well, we can actually use a Venn diagram to solve this problem. How many different circles will my Venn diagram have? It's just 2. What will the circles be? Wrote and produced. Those are my 2 circles. So I just need 2 circles on this one. You can call your circles A and B if you want. I'm actually going to call my circles what they represent. This is the wrote circle, and this is my produced circle. And here's the universal set on the outside. That is Joe Long, or his career. This one says he wrote and produced 2, he wrote 5, he produced 7, he worked on 12. Where am I going to start? What they have in common. That overlap in the middle, which will have how many in it? 2. The 2 here in the middle comes from this piece right here. He wrote and produced 2. And that means you've got the overlap, the intersection. Can we move on to the 5 projects? It says he wrote 5. So there's 3 out here. Don't be tempted to put a 5 out there. That's not what it said. There's only 3 on the outside there. Because the whole circle that we called wrote have to add up to 5. Because it represents everything you wrote. Okay, make sense?
Yeah, I thought that when you abbreviated in the second circle the PROD, I thought that was for project. And I was like,
Oh, product, or produced actually is what we're doing, yeah, produced. All right, the last piece of this 3 written down here, it says he produced 7. So do I put a 7 out here? No, I put a 5 out here because
It's in the
5 and the 2 in the middle have to add up to 7. So how many projects do I currently have inside of my Venn diagram? 10. How many am I supposed to have? 12. So I'm missing 2 that go on the outside. So apparently he worked on 2 others in some capacity that was not writing or producing. Maybe he sang. I don't know. But he did something. So questions to follow will be based on the diagram. So the diagram will tell us what to fill in. It says, how many projects did he write and not produce? 3. How many did he produce and not write? 5. And how many did he neither write nor produce? 2. The questions are easy after you do the Venn diagram, right? You should be able to just look at the Venn diagram and answer them. Okay? Alright, let's do one that's a little bit more going on. A youth group asked questions regarding the songs they learned as children. Upon surveying 34 youth, the following results are obtained. 15 had learned Jesus Loves Me. 18 had learned This Little Light of Mine. 28 had learned the B-I-B-L-E. 13 had learned both Jesus Loves Me and the B-I-B-L-E. 15 had learned both This Little Light of Mine and the B-I-B-L-E. 14, This Little Light of Mine and Jesus Loves Me. And 13 had learned all 3. Just take a deep breath. A lot of songs going on. And then we've got some questions about these songs and these students and so forth, right? And we can use, so I get this, yep. We can use a Venn diagram to do this problem. How many circles are in my Venn diagram? 3. And there's 3 different songs, right? Okay, so we've got Jesus Loves Me up here. We've got This Little Light of Mine over here. And we've got the B-I-B-L-E on the bottom. And if yours are in a different spot, it's no problem. Okay? Here's my universal set U on the outside. Alright, so where am I going to start? The middle. And what's going to go in the middle, Hannah? 13, because 13 had learned all 3. I did that piece now. Now what?
You go to the intersections.
And their intersections are the 3 lines above that, right?
Yeah.
So all 3 of these we can do them in any order we'd like. Let's just start from the bottom and work our way up. Okay, so on the bottom it says 14 had learned This Little Light of Mine and Jesus Loves Me. So Jesus Loves Me, This Little Light of Mine is these 2 regions. 1 will go in there. Right. This next one up, 15. This Little Light of Mine and the B-I-B-L-E. So that's my right hand side of my graph. Light and the Bible and 2. Right. The next one up from that is Jesus Loves Me and the B-I-B-L-E.
So 0.
Yeah, it's going to be a 0. That's okay. We can have a 0 in there. No negatives, but we can certainly have a 0. Alright, so we did all the intersections. Now what? Now we can do any of the top 3 pieces, right? So since I'm going bottom up, let's just keep going in that direction. I have 28 learned the B-I-B-L-E. So right now the B-I-B-L-E circle is the bottom circle. I've got 13 and 2. How many are missing? 13. I need 13 more down here on the bottom to add up to that 28. 18 learned This Little Light of Mine. So I need 2 more out here to make that 18. And then 15 had learned Jesus Loves Me. I just need 1 more on the outside over here. And what's missing? The part that's on the outside, right, of you. So what am I going to do to find that? So did you tell me it was 2? Because how did you get 2, Hannah?
Because there's 34 total, and when you add up all the circles, it comes to 32, so you're short 2.
Okay, so if we add up all the circles, Hannah tells us it comes to 32. We're supposed to have 34, which means I'm missing 2 of the kids that were surveyed. So they go out here on the outside. And then once we have our diagram, we can answer our questions. So A says, how many learned exactly one of these songs? So if I'm looking for exactly one of these songs, what numbers in this diagram am I looking at? Or what location? Let's say it that way. What location of the diagram am I looking at?
The big regions.
The big regions of each circle is a really good way of describing it. So it's these outer regions where the 1 here is, the 2 here is, and the 13 here is. Those are people who learned exactly 1 of those songs. This is 1 plus 2 plus 13 for a total of 16. So 16 had learned exactly 1. How many had learned at least two? What does at least two mean? Two or more. So in this case, it would be 2 or 3. So in the diagram, what am I looking at? The sections around the middle, so and including the middle too, right, Katie? Yeah, because I'm going to learn 2 or 3 songs. So 13 in the middle had learned all 3. The 1 on the top, the 2 on the side, and the 0 had learned also, just 2 of them. So I have 1 plus 2 plus 13, but they're different locations that I got those from. Recognize, right? But that's still 16 kids. How many had learned none of the songs? The 2 on the outside. And how many had learned this light of mine, this little light of mine, but no others? 2. And that's the 2 that's on the outside right here. Right? Any questions on working through these pieces of information? The biggest thing to keep in mind is to remember that you don't just put the numbers that you're seeing into the picture. You have to do some adding and subtracting to figure out what goes into the picture. Okay, we got one last question. Are we good to go? One last slide. Are we good to go on to it? Okay, 2 questions on the slide. Example 6 says, is the operation of the Cartesian product commutative? Why or why not? So let's remind ourselves, what does commutative mean? Do you remember? Okay, can you give me an example? Alright, so addition is commutative, right? 2 plus 3 is the same as 3 plus 2, so we can switch the order. Okay, so do you remember what we talked about when we did Cartesian products? What were those? Pairs. That's what you want. They're ordered pairs, right? So they were pieces where I had like this going on. Those were the elements of my set. The first element came from one set, the second element came from some other set, and we paired them together. Okay? So the question is the Cartesian product commutative? That is to say, if you had A, B, would it necessarily and always be the same as B, A? Kinsey says no. Morgan says no. Why not? How do you know the answer is no?
I mean, I don't know if this is answering the question, but I think of it like on a graph, if you had 2, 4, that's not the same as 4, 2, it's different location.
And that's exactly the right idea. That's exactly the right idea. So you know a concrete example where it doesn't work, and that's what you're being asked to find. Is this always going? Like sometimes this would be okay, right? If the pairings were simply pairing up people to dance or something, it doesn't really matter if I choose the guy first or choose the girl first. They're a pair when they're done. That's fine. But that's not always what we mean by learning this pairing. You know an example where this doesn't work. So the answer is no. And because let's say that you had the ordered pair 1, 3, that does not equal 3, 1. We'll say it the way that you did, Marilyn, on a graph. Right? They're different locations on a graph. So no, this doesn't always work. So it is not, in general, commutative. Next one, number 7. A student argues that adding 2 sets and taking the union of 2 sets is the same thing. How do you respond? Throw a pin at him, right? No, not how you respond. So adding 2 sets and taking the union of 2 sets is the same thing. What do you think? You know what taking the union of 2 sets looks like, right? From a picture point of view. What in the world does adding 2 sets look like? So you have to be careful because we've never defined what adding sets together even means. What you're thinking of, though, Katrina, is we've talked about what it means to add the cardinal numbers in the set, how many items are in the sets, and then we have the repeats. Well, it is the issue, but not for quite the reason you're thinking. So I'm going to come back to the question that Nicole asked in the earlier section. Do you remember the phrase that it used? I'm going to try to you guys comprehend what it meant. What was that word? Well defined. addition is not well defined. In fact, we didn't define it at all, did we? There isn't such a thing as addition of two sets. It doesn't exist. There's unions, there's intersections, and then there's that thing that we call Cartesian products. Remember that? So addition of two sets, we don't have that. I don't have to write down. Let's say it this way. Addition is not an operation on sets. It's simply not one of our operations. We can add cardinal numbers, which is what Trina was referring to, but we don't have the addition of two sets. Like, what is A plus B? Well, we don't have A plus B. We have A union B and we have A intersection B. We've got some complements thrown in there, but the only way we join A and B is either with unions or intersections. Okay? So, let me say that though. So, but we can add cardinalities. And the cardinality that we're talking about is if we were to take the union and we were to talk about the number of items in the union. Do you remember the formula here? How do I find the number of items in the union of two sets?
It's the intersection.
Mm-hmm. So there is a relationship between addition and between sets, but it's between the number of items in those sets, not the sets themselves. So if we wanted to know the union, or the number of items in the union, we can add the items in each individual set, and then we can remove the part that they have in common because we counted it twice. That's the relationship that exists that the student's possibly referring to. Or they might possibly be referring to this idea that if they're disjoint, right, then this n at A intersect B and n becomes 0 and it goes away. That's another possibility. All right, any questions on that one?